Good day everyone, this is ECA23 Task Performance Task 11, which is the filter bank multi-carrier modulation. In this topic, it will covers the definition of the Fbmc and the pros and cons, its history, the comparison, the types of Fbmc, the application of Fbmc, and the summary of the Fbmc. And by the way, this is Dean Evander C. Dagum from BSECE 3C. First, we have the definition of the Fbmc. Fbmc, or the filter bank multi-carrier modulation, is a type of multi-carrier modulation in which the carriers are filtered to produce a waveform that is more spectrally efficient. Fbmc, a multiplexing modulation combination technique that divides a wideband channel into a number of bandpass subchannels. Here, we have the pros and cons. The advantages of the Fbmc are the following. Fbmc is able to provide a spectrum efficient and more selective system. The cyclic prefix CP required for OFDM is not needed, thereby freeing up more space for real data. It also provides robust narrowband jammers. Here we have the disadvantages of Fbmc. The use of MIMO with Fbmc is very complicated, and as a result, few systems have investigated the use of these two techniques together. The design of wide bandwidth and high dynamic range systems with Fbmc provides some significant RF development challenges. Fbmc is more complicated than OFDM. It introduced an overhead overlapping symbols in the filter bank and the time domain. Next is the history of the Fbmc. Many attempts have been made in the past to include Fbmc into various standards. According to Janes et al. Of Aware Incorporation, the first suggestion to use Fbmc for multi-carrier communications was made at one of the asymmetric digital subscriber lines, or the ADSL standard, meetings in 1993. The proposed method that was called discrete wavelength multitone, or the DWMT, and was not included in the ADSL standard, despite the enthusiasm of the research community. This was largely due to the method's apparent complexity when compared to its rival. DMT, Janes et al. Postulated a WMT structure that was substantially more complicated than DMT. The equalization approach used contributed significantly to the complexity of DWMT. The extensive description assumed that an equalizer is required to integrate signals from each subcarrier band and its neighboring bands. The average length of an equalizer indicated was 21 real valued taps per subcarrier. The author of this work later pointed out that if each subcarrier is thin enough to be approximated by a flat gain, 2 real taps per subcarrier would be enough for equalization. Filtered multitone was the name of the suggested approach, or the FMT. A number of researchers produced this suggestion, which was included as an annex in one of VDSL's original draft documents. FMT, on the other hand, was not included in the final VDSL standard document to avoid incompatibility with ADSL. An attempt by France Telecom to include Fbmc in the IEEE 802.22, a cognitive radio standard for accessing TV bands in wireless rural area networks, was also unsuccessful, or WRAN. The TIA's Digital Radio Technical Standard appears to be the only standard for radio transmission that employs Fbmc so far. Next is the comparison. The comparison is the Fbmc versus the OFDM. When carriers modulated is an OFDM system, side lobes spread out either side with a filter bank system. The filters are used to remove these and therefore a much cleaner carrier results. Fbmc has much better usage of the available capacity and is able to offer higher data rates within a given radio spectrum. Cyclic prefix is not required in Fbmc. Next is the types of the Fbmc. First, there are three types of BMC, which is the cosine modulated multitone (CMT), the filtered multitone (FMT), and the offset quadrature amplitude modulation (OFDM) or OQAM/OFDM. First, we have the cosine modulated multitone (CMT). CMT uses the cosine modulated filter bank, which is the early Fbmc modulation technology in the field of digital subscriber line or DSL. It has been applied in the field of wireless applications recently. CMT is not only has a high bandwidth efficiency but also has a blind detection capability. Due to the reconstruction performance of CMT, the overlapping adjacent bands can be completely separated when the multiple neighbors' frequency bands are transmitted at the same time. Next is the filtered multitone or the FMT. FMT is another form of Fbmc modulation. Compared to CMT, the subscribers of the FMT are not overlapping between the adjacent frequency bands in order to avoid the overlapping of the subcarriers. The guard band should be added between the subcarriers. Due to the use of the guard interval, the FMT system will waste some bandwidth. Therefore, the main difference between CMT and FMT lies in the use of special frequency bands. Next is the offset quadrature amplitude modulation based OFDM. Recent Fbmc technique is referred to as OQAM/OFDM. Compared to CMT and FMT, OQAM/OFDM has the highest stop band attenuation for a fixed filter length and the number of carriers. According to the characteristics of OQAM, the transmission symbols of the OQAM/OFDM communication systems are the real and imaginary parts of the complex quadrature amplitude modulation symbols, and the transmission time interval is half of the symbol period between the real and imaginary symbols. In addition, the reasonable design of the prototype filter can ensure the frequency response of each subcarrier has a better roll-off of characteristics for reducing the spectrum leakage of subcarriers. Many scholars have been designed suitable filters for Fbmc. The filter using the frequency sampling technique has been considered as the reference prototype filter of the European project PHYDYAS. Leaflocks gives an overview of the main features concerning is isotropic orthogonal transform algorithm or the IOTA. The authors formulate a direct optimization problem of the filter impulse response coefficient for the Fbmc system to minimize the stop band energy and constrain the ISI over ICI. It is attempted to design the prototype filter by performing time frequency analysis on the ambiguity function of isotropic Hermite pulses. Beside the research of prototype filter, people have made plenty of contribution to improve the performance of Fbmc structure. A novel architecture for MIMO transmission and the reception of Fbmc modulated signals under strong frequency selectivity channel is presented. An improved partial transmit sequence or the PTS scheme by employing multi-black joint optimization (MBJO) for the PAPR reduction of Fbmc signals is proposed. A novel scattered pilot method of channel estimation in Fbmc frequency offset compensation methods for Fbmc in the context of frequency division multiple access or the FDMA. A data-aided joint maximum division likelihood ML estimator of carrier frequency offset or the CFO and the channel impulse response for the oversampled perfect reconstruction filter banks transceivers are proposed. and the spectral efficiency of Fbmc-based CR networks is studied in here. In short, Fbmc has made some achievements in various aspects. To conclude, the Fbmc is technique could all theoretically offer a significant bandwidth efficiency advantage over OFDM due to their special filter banks based structure and the elimination of cyclic prefix or CP. On the other hand, among the different Fbmc techniques, OQAM-OFDM is preferred to be a suitable choice for CR applications since FMT and CMT are originally introduced for DSL applications and will be impractical and hard to meet the CR system requirements. In this chapter and otherwise stated, the Fbmc refers to OQAM-OFDM. The next is the applications of the Fbmc. The first application is the application to cognitive radio. First, we have the spectral efficiencies comparison in single cell system or the system model. As you can see here, this is the system model. The system model of single CR cell including multiple users. The solid lines with arrow stand for the links, producing the capacity. The dashed lines with arrow stands for interference links. In the context of CR systems, a group of SUS randomly distributed with an accessing point called secondary base station or the SPS constitutes a CR cell as depicted in this picture. The uplink scenario of CR system incorporates a primary cell and secondary cell with multiple PUs and SUS. Next is the spectral efficiency comparison in single cell system or the system model. The neighbor frequency interference resulting from spectral leakage. Generally, due to the spectral leakage and imperfect synchronization between SU and PU, the out-of-band radiation of a subcarrier will be regarded as interference. If the spectrum holes adjacent to the PUs are occupied by the SUS, the PUs may suffer from the intercell interference. For the guarantee of the quality of service QoS of PUS, the interference constraint must be considered to the limit interference by the SUS. The distributions of PUs and the spectral holes are depicted in the next slide. Spectral efficiency. Next is the spectral efficiency comparison in single systems or the system model. The diagram of idle and occupied frequency band as a band incorporates incorporation. Here, assuming that the whole bandwidth is divided into 48 subbands, each subband includes L is equals to 18 subcarriers. A spectrum hole meaning incorporate many subbands. Thus, BC and idle subbands are represented by 1 and 0, respectively. 1 means the occupied frequency bands by PUS, and 0 means the idle frequency bands to be dynamically accessed by SUS. Assuming that the SBS can perfectly sense the idle bands of the primary system and the SUs in the CR cell are synchronized, the spectrum sensing error is not in consideration. Therefore, the concentration is located in the RA scheme. Next is the spectral efficiency comparison in single systems or in resource allocation. We have the three resource allocation here under the spectral efficiency comparison in single cell systems. First, we have the subcarrier assignment. Here, the first task of subcarrier assignment is the bandwidth allocation. From the view of fairness, the issue which exhibits the minimum average capacity always increases. the number of its subcarriers until the total number of subbands assigned to SUS equals the number of free subbands. This mechanism helps to promise that each SU can achieve the fairness, assuming that F is the number of the free subbands, the number of SUS is M, F is greater than M, and NI stands for the number of subbands assigned to the ITH user. Next is the power location. The power location here is in this subsection, the focus is on the problem of power allocation. At the premise of knowing the results of the subcarrier assignment, the power allocation of multi-user system can be virtually regarded as a single user system. Hence, the task becomes a nonlinear programming, which can be efficiently solved by the some algorithms, such as the Lagrangian multiplier in the gradient projection method, or the GPM. Next is the estimated channel state information, or the CSI. Generally, it is not practical to assume that the perfect CSI in RA problem is available due to the channel delays and the inaccuracy of channel gain estimation. There is always an estimation error between estimated CSI and ideal CSI. Thus, the estimated CSI has more practical significance in communication research than the ideal CSI. Next is the numerical results, which is under the spectral efficiency comparison in single system. So this is the simulation parameters of the single CR cell systems. Here, this is the what you call the spectral efficiency of Fbmc. And the other three modulation waveforms are evaluated by using the above mentioned RA algorithm. We analyze channel capacity of these waveforms in single CR cells systems for four aspects: the distance d between SBS and the PBS, the maximal power of SUS path, SUS PTH, the capacity loss coefficient lambda, or the PU of PU, and the outage probability P out of PU. The simulation parameters are shown here. This is the simulation here, or the table. Next is the relationship of capacity and distance between PBS and SBS. The impact of the distance between SBS and PBS on spectral efficiency is investigated. It can be seen that accompanied by the increase in the distance, the capacities of all waveforms arise in the curves tend to merge asymptotically. The increase in D reduces the mutual interference between the PU and the SU, which is the reason why the average capacity increases. The effect of the maximal power of SUPTH is assessed in here. We can obtain the spectral efficiency of all waveforms increases with the augmentation of PTH. At the premise of satisfying the constraints, the larger power of SUs means that the more power is allocated to the spectrum holes, which results in the expansion of channel capacity. Next is the relationship of capacity and interference threshold. Here, it depicts the inherent interaction of average capacity and the capacity loss coefficient of PU. When less capacity loss is prescribed by PUS, which means a lower interference threshold and better protection for primary system. The achievable capacity degrades due to the more strict access control. Next is the relationship of capacity and the outage of probability of PU. Here, it represents the relationship of spectral efficiency in the outage probability P out of PU. Note that the average capacity of OFDM based CR system with estimated CSI collapses when a low outage probability is prescribed, while other MCM based CR systems are much less vulnerable to different outage probabilities. Next, under the spectral efficiency comparison in single system is the discussion of spectral efficiency in single cell system. First, the output of the numerical results exhibit that the average capacity of Fbmc outperforms those of other three waveforms. No matter what factor is considered, Fbmc is always has the highest spectral efficiency on the basis of capacity due to its slightest spectral leakage. OFMC comes second. GFDM takes the third place and the OFDM is the last. It implies that the less spectral leakage leads to the higher spectral efficiency in single CR cell systems. Second, we can see that there is channel capacity gap between the case of ideal CSI and the case of estimated CSI for the 4 MCM based systems. It is easily found that the spectral leakage property also plays an important role when the estimated CSI is considered. For the OFDM based CR system, there is a large channel capacity gap between the case with ideal CSI and the case with an estimated CSI. While there is a slight capacity difference by applying the GFDM, UFMC, and especially the Fbmc-based CR systems, which could be explained by the fact that when a low outage probability is required, more subcarriers adjacent to PU should be deactivated or underutilized for OFDM due to its significant spectral leakage, which accordingly decreases the channel capacity. Last application is the application to 5G networks. Beyond 4G communication system will be highly flexible and more congested. This is because of the increased demand for wireless applications, such as machine-type communication of the MTC. Aside from the cellular mobile communications, hence the need for the next generation, which is the 5G, becomes essential. In the 4G systems, the cyclic prefix orthogonal frequency division multiplexing, or the CPOFDM, has been adopted as a modulation technique. However, CPOFDM suffers from the spectrum waste problem because of the high outband, or the OOB emission. Thus, not all frequency spectrums will be useful. On the other hand, they required increased demand, where for high data rate motivated the industry to find another candidate as a modulation technique to be adopted in the next generation. Different candidates have been introduced. The filter bank multicarrier, or the Fbmc, is one of the promising candidates for that job. In this paper, we will show that the Fbmc can be employed in 5G communication systems and can exploit almost all the advantages of the previous CPOFDM system with little increment in the complexity, such as the implementation of multiple input, multiple output, or the MIMO, antenna diversity, and the high throughput with noteworthy mobility speeds. Last is the summary. The summary in this chapter, the spectral efficiency comparison is conducted by analyzing the achievable channel capacity among 4 different multi-carrier modulations. 2 RA algorithms with practical consideration of estimated CSI are designed for evaluating and comparing the capacity performance. Simulation results show that in our scenarios, Fbmc can offer the highest channel capacity and can achieve much more performance gain if rough estimated channel state information is considered. As a result, we conclude that the little spectral leakage of Fbmc plays an essential role in achieving high spectral efficiency, and further verify that Fbmc is a competitive candidate for 5G physical layer data communication. Again, this is Din Evander C. Dagum from BSECE 3C. Thank you.